Hi, second graders. Miss Diorio here from Citizenship Academy, and we are on Module 8, Lesson 7 today. You're going to want something to write with and something to write on. We're going to start off with some subtraction problems and our application problem before we get to our shapes. So grab those things first, and then we'll get started. So our lesson today is going to be breaking down our composite shapes that we've learned, so our triangles, our trapezoids, our squares, into equal halves, thirds, and fourths. And I'll show you what that means in a little bit. What I want us to do to start is to practice our subtraction. You can solve these problems using a place value chart, using the vertical method, using number bonds, whatever way works best for you. I want you to take a minute and review how to do our subtraction. All right, so here's our first problem. I want you to write it down on your board and solve it, and then we'll come back together and do it together to go over it. All right, so pause and do that now, and then we'll go over it. Ready? Okay, so I like solving with the vertical method. The first thing I'm noticing is that I can't take 8 away from 1, so I'm going to have to borrow from my tens place. I'm going to take a 10 away, add 10 here. 11 minus 8 is going to give me 3. 5 minus 1 is going to give me 4. 100, and there's nothing there. It just comes down. So we get 143. Awesome job. All right, let's try another one. Go ahead, write this down, solve it in whatever method works best for you, and then we will go over it. 152 minus 29. We'll pause and solve and come back when you're ready. All right, same thing with this one. First thing I'm noticing is that I can't take 9 away from 2. So I'm going to get some extra ones from my tens place. I'm going to take a 10 away. My 5 turns into a 4. I'm going to add 10 ones to my 2, and I get 12 ones. 12 ones minus 9 ones gives me 3 ones. 4 ones minus 2 ones. 4 tens minus 2 tens gives me 2 tens. And I keep my 100 the same. Awesome job. A little bit bigger number this time. 237 minus 56. Go ahead and pause and solve in the way that works best for you. All right, let's go over it. So I always start with my ones place. Now my 7 is bigger than my 6, so I can subtract. 7 minus 6 gives me 1. Now in my tens place, I cannot take 5 tens away from 3 tens. So I'm going to borrow from my hundreds place. I'm going to add 10 tens. And we get 13 minus 5 is going to give me 8. Like bad math, I'm sorry. And then my 100 stay the same. I end up with 181. Awesome job. All right, last one. Go ahead and solve 319 minus 28. Solve in the way that works best for you. Pause the video and come back when you're done. All right, let's do it. Let's start with our ones place. We can take 9 ones away from 8 ones, or we can take 8 ones away from 9 ones, and we end up with 1 1. We cannot take 2 tens away from 1 10, so we're going to borrow from our hundreds place. We're going to borrow 10 tens, and that's going to give us 11 tens minus 2 tens gives us 9 tens. 2 tens minus 0 tens. 2 hundreds minus 0 hundreds gives us 2 hundreds. We end up with 291. Awesome. All right. Let's get into our application problem today. Here we go. Mrs. Librarian students are picking up tangram pieces. They collected 13 parallelograms, 24 large triangles, 24 small triangles, and 13 medium triangles. The rest are all squares. If they collect 97 pieces in all, how many squares are there? Okay, so again, this is a 2-step word problem. What is our first step going to be? What's the first thing we're going to need to figure out? Good. how many pieces that we know they collected. So they collected 13, I'm going to write this down, 13 parallelograms, 24 large triangles, 24 small triangles, and 13 medium triangles. Now, what do we not know? What do we need to figure out? Yes, how many are squares? We don't know how many are squares. What we do know is that we collected 97 in all. So your first step is to figure out how many we know, and then we want to figure out what we know plus our squares is going to equal our 97. All right, so go ahead, pause the video, try it on your own, and then we'll come back and go over it. All right, let's try it together. So we're going to add up first what we know. There's different ways to do this. I like trying to add our tens up together. Sometimes I like to add like terms, so I know this plus this is going to give me 26, and this plus this is going to give me 48. Different ways to do it. Whatever way works for you is fine. We should get a total of 74. Now, we still don't know how many squares we need, so I set up a number sentence. 74 is what we do know, plus the number of squares is going to give us 97. So to figure that out, just like we do in our number bones, we're going to do 97 minus 74, and we're going to get a nice 23. So what does that 23 mean? That 23 of our shapes are squares. Awesome. All right, let's get into some shapes. What shape is this? Triangle. Perfect. How many parts are there in this triangle? I drew a line straight down the middle. How many parts are there now? 2. Very good. Are both of those parts, if that triangle is split down the middle, are both of those parts equal? Are they the same size? Are they the same shape? Do they have the same space inside of them? They do, right? So when two parts of a shape are the same, are equal, we call those two equal parts halves. You say halves. Now the two parts have to be equal in order to be halves. Otherwise, they are not halves. So all of these shapes have two halves or two equal parts. They must be equal. They must take up the same amount of space. Otherwise, they are not halves. So as you can see in these three shapes, it's the same amount of space in all three parts. Same thing with this one. So this is a hexagon. As you can see, we drew a line down the middle. What smaller polygon do you see when we split the hexagon in half? What smaller polygon would fit in this shape up here? A trapezoid, good. How many trapezoids make up one hexagon? 1, 2. Awesome. All right, so now we're going to get into thirds. Similarly to halves, thirds have to be equal parts. When a shape can be split into 3 equal parts, we call those thirds. So now we have a trapezoid. Which 3 smaller polygons do you see in this shape? Triangles, good. 1, 2, 3 triangles, and all 3 are the same shape, so they are called, same size, so they are called thirds. We call 3 equal parts thirds. Same thing here. We have 3 equal parts. They are thirds. What smaller polygons do you see in this hexagon? We see 3 equal shapes, 3 equal parts. What smaller polygon is that? A rhombus, very good. And you see 3 rhombuses, and they are thirds. Awesome work. Okay, so in your problem set today, you're going to see a bunch of different shapes. What you need to do is choose the shapes that show halves. There we go. If it is not equal, it is not a half. So I want you to look at these shapes on your screen. Which of these shapes show halves? They have to be equal parts. Very good. Equal parts. Equal parts. Equal parts. If we draw a line down the middle of this, is this shape equal to this shape? Not at all. So this is not halves. We cannot circle that one. All right, try this one. Which shapes show thirds? Remember, thirds have to be equal parts. All three parts are equal, same, take up the same amount of space, same shape. Which shapes show thirds? Good. This first one, and then the yellow hexagon. This middle one, these three parts are not the same size. They are not equal. They do not show thirds. Nice job. All right. Now, fourths are when we're split into 4 parts. Remember, they still have to be equal. Which shapes show fourths? Equal parts. 4 equal parts. Very good. Just the 2 yellow ones. This one has 4 parts, but they are not equal. They are not the same size, so this does not show fourths. Awesome work. So on your exit ticket today, you're going to do the same thing. You're going to check off the boxes for the shapes that show halves, show thirds, and show fourths. That's it. Good job, guys.